Hello everyone, welcome back to our channel Python with GEC Bharuch. My name is Subham Das. Today I will talk about histograms and box plots in Seaborn using Python. These are important tools for showing data in a clear way. Let's get started. Today we will explore the exciting world of data visualization. So what is data visualization? It is the graphical representation of information and data, which plays a crucial role in making complex data more accessible and understandable. Data visualization helps us identify patterns, trends, and insights that may not be apparent in raw data. By presenting data visually, we can convey our findings effectively, aiding in decision making and storytelling. In this presentation, we will focus on two powerful tools for data visualization: histograms and box plots, and we will learn how to create them using Seaborn in Python. Now let's take a deep dive into histograms. A histogram is a graphical representation that organizes a group of data points into a user-specified ranges known as bins. It displays the frequency of data points in each bin, allowing us to see how data is distributed across different intervals. The primary purpose of a histogram is to help visualize the distribution of numerical data. It allows us to identify the central tendency, variability, and shape of the data distribution. Some key features of a histogram include bins, which are the intervals that group the data points, and the height of the bars, which represents the number of data points in each bin. With this understanding, let's move on to how we can create histograms using Seaborn in Python. Histograms are powerful tools for data analysis for several reasons. First, they help us understand data distribution by visually representing how data is spread across different values. They are excellent for spotting outliers, which are data points that fall far outside the normal range, helping us identify unusual observations. Histograms also allow us to analyze data spread, providing insights into how concentrated or dispersed the data is across various ranges. Finally, they facilitate comparisons between different datasets or groups, making it easier to see differences in distributions at a glance. By using histograms, we gain a clearer understanding of the data we are working with, which is essential for effective analysis. Now let's look at a practical example of how to create a histogram using Seaborn. Here is the code. In this example, we are loading a dataset called tips that contains information about restaurant bills. The fourth line creates a histogram of the total bill amounts, dividing the data into 20 bins. We also set KDE equals to false, which means we are not including the kernel density estimation curve for this plot. The title and labels help make our plot more informative, indicating exactly what we are analyzing. When we run this code, we visualize how total bill amounts are distributed, helping us understand spending patterns at the restaurant. Customization is key when it comes to making our histogram more informative and visually appealing. Here are some options. We can change the number of bins. More bins allow for finer detail, while fewer bins provide a broader overview of data distribution. We can also add a KDE curve, which is a smooth line showing the estimated probability density function, providing additional insights into data trends. Utilizing colors in our histograms can help differentiate between various data groups or emphasize specific areas, enhancing readability. Lastly, we can choose to show density instead of counts, which normalizes the histogram and allows for better comparison across different datasets. By using these customization options, we can tailor our histograms to better suit our analysis needs. In conclusion, histograms provide a powerful visual representation of data distribution. They allow us to identify the shape, spread, and central tendency of our data. Now that we have a good understanding of histograms, let's move on to box plots. A box plot is an essential visualization that summarizes the distribution of a dataset using 5 key statistics. The minimum is the smallest data point, excluding any outliers. Q1 represents the median of the lower half of the dataset. The median is the middle value of the dataset, providing insight into central tendency. Q3 indicates the median of the upper half of the dataset, and the maximum is the largest data point, again excluding outliers. In terms of its structure, the box shows the interquartile range IQR, which represents the middle 50% of the data. The whiskers extend from the box to the minimum and maximum values, while outliers are data points that fall outside the whiskers, indicating unusual or extreme values. Box plots are particularly useful for understanding data distributions and identifying any unusual observation within datasets. Box plots offer several advantages that make them valuable tools in data analysis. They allow for easy comparison across groups, making it straightforward to visualize differences in distributions. They help us identify outliers which may require further investigation to understand their impact on the dataset. Box plots also provide insight into the spread and central tendency of the data, helping us grasp where most values lie and how they are dispersed. Finally, they serve as a visual summary of large datasets, allowing us to communicate findings efficiently and effectively. By utilizing box plots, we can gain a comprehensive understanding of our data in a visually appealing format. Now let's look at an example of how to create a box plot using Seaborn. Here is the code. In this example, we again use the tips dataset. The fourth line creates a box plot showing the total bill amounts for each day of the week. The x-axis represents the days, while the y-axis shows the total bill amount. This visualization allows us to see the distribution of bills across different days, helping us identify any trends such as which day has the highest average spending or if any days have significant outliers. When we run this code, we get a clear visual summary of how total bills vary by day, allowing us to draw meaningful insights. Just like histograms, box plots can be customized to enhance their readability and effectiveness. Here are some customization options. We can change colors to distinguish between different groups within the data, making our plots more visually appealing. Adding notches to the boxes indicates confidence intervals around the median, giving us more statistical insight. We can adjust whiskers to modify their length, which changes how we define outliers and can provide a different perspective on the data. Finally, we can overlay sum plot on top of the box plot to show individual data points. This adds another layer of detail, allowing us to see how the data is distributed within the box plot. By employing these customization techniques, we can create box plots that are not only informative but also engaging for our audience. In conclusion, we have learned that histograms and box plots are essential tools for data visualization. Both types of plots help us understand data distribution and identify patterns, making them invaluable for data analysis. Using Seaborn, we can easily create and customize these plots to suit our needs. I encourage you to experiment with different datasets and explore the various customization options available. Practicing with Seaborn will significantly enhance your data visualization skills and enable you to present your data more effectively. Thank you for watching. If you have any questions, feel free to ask in the comments, and don't forget to like and subscribe for more content on data science and visualization.